In this experiment, we are going to study Zener diode as a voltage regulator. This is the circuit diagram. Here you can see this is the step-down transformer. In India, input voltage is 230 volt. Output voltage maybe 6 voltage or 9 voltage. Here we are getting here 6 voltage. Actually it is center tap transformer 606. This is not required, therefore we have used only 2 terminals. Then this is the bridge rectifier circuit. Here this is the bridge rectifier circuit. Here all the cathodes are connected in upward direction, where anode and cathode combines, that is connected to transformer, this terminal and this terminal. Where both the cathode joins together, that gives the positive supply, and where both anodes gets connected, that is connected to negative. This is the filter capacitor, this filter capacitor. So transformer, rectifier, filter capacitor. Transformer, rectifier, filter capacitor. Then the Zener together with RS work as a voltage regulator. Means it keeps constant output voltage. It keeps output voltage constant irrespective of the change in input voltage or change in output load current. Here you can change input voltage with the help of auto transformer or thermostat, and to change the output load current, here potentiometer is used, and in this circuit different resistors are connected in series. Value is 1 kilo and each resistor is 100 ohms. 100 multiplied by 10 is equal to 1 kilo. So instead of 1 kilo, we have used 10 100 ohms resistor. So this is 33 ohms resistor. This is 5 volt Zener diode. In between these two is this terminal. You can see in between these two terminal, current meter is connected. Here we will connect current meter in next part, that is the load regulation. First we will do line regulation. In line regulation we are varying only input voltage. So these two terminals are connected together or shorted. Zener output terminal is connected at this point also. This terminal is also we will use in load regulation. Here it is useless, so just connect to unused tag terminal. So this is all about the circuit diagram. Once again repeating, this is rectifier circuit, bridge rectifier, 4 diodes. This is filter. This is series resistor. This is Zener diode. Then there is a provision to connect current meter in load regulation, and these 10 resistors constitute 1 kilo total resistance value. So it is a very simple circuit, you can see. Now this meter is connected at the output side. The other end of the meter is connected here. You can see Now let's take this auto transformer. This is the auto transformer. Here it starts from 0 and highest possible value is 270. I have kept it at 160 voltage. You can see this 160 voltage. So at 160 voltage, output is 4.4. Now let's increase 170. It is 4.5, it means you can say 4.6. So let's write this. Then increase in terms of 10, difference of 10 voltage. Now it is 180. It is 4.66. Here you are seeing maximum is 4.90. That is at 4.91 at 270 degrees. So at 190 it is 4.71. At 200 it is 4.76. Then 210 4.80. At 220 4.83. At 230 4.85. This is the nominal voltage. In India, normal voltage is 230 voltage. Then 240 4.90. At 250 4.91. At 216 4.92, and last it is 4.93. So these are the readings. Now to find out the percentage source regulation, you have to take numerator change in load voltage for full line voltage from 170 to 270 divided by V nominal. It means for 270 you got 4.93 minus for 170 you got 4.6 upon V nominal, that is 4.85. So let's calculate this. .8%. This is the percentage source regulation. If you compare with 317, 317 is far better than Zener diode. Their variation percentage source regulation, percentage load regulation are just 0.1%. So their variation is very, very small. But here you are getting 6.8% variation. Now let's continue load regulation. For load regulation we do not require this, so you can bypass this. You can directly connect, you can remove this and you can directly connect to I have connected here. Or if you want to keep this, you can fix at 230 volt and then start taking a reading. Here I have removed this. Now, as I told earlier, you have to connect current meter in between these two terminals. So let's connect one more meter between these two terminals. Make sure that these two terminals are not shorted together. This as it is. This meter is measuring voltage. This meter is measuring current. So keep it in on a maximum, that is 200 milliampere. Please note that if any reading it start increasing above this 200 milliampere, then we are not able to measure using this meter. So now I am switching on supply. Here you are seeing this is current, this is voltage. Current is kept on 200 milliampere. This voltage is kept on 20 range. Here it is showing 4.8 voltage. 4.8, it means approximately 4.9 voltage. This is not connected to any of these resistors. Now when I connect this terminal, means this is already grounded. So when I connect this terminal here, it means this 100 is bypassed. So 900 ohms resistors come in series. So for 900 ohms you are getting 4.88. For 900 current is, this is IL milliampere, is 117.2 milliampere and voltage is 4.87. For 800 it is 131.3 milliampere. This is current and it is 4.87. You are seeing that this voltage remains constant, but here resistance goes on decreasing and current goes on increasing. For 700 current is 153 and this voltage is 4.87. Next, for 600 it is further increased to 166.4 and this is 4.86. Now this is 500. Now here, since the current is above this range, therefore we cannot see here, it is above 200 milliampere. So let's just write greater than 200 milliampere, and it is not visible. Voltage is 4.85. I am repeating this. See, up to this, that is 600, you can measure current. But when I change to 500 ohms, current is about 200 milliamperes. That is why here it is showing I for infinity. This is also same, that is 500, voltage 4.85. This is for 400, current is greater than 200 milliampere. This is 4.84. Then for next 300 ohms, you see it is 4.81. Then for 200 ohms, 4.75. This is 100 ohms. For 100 ohms, it decreases to 4.4. And if you connect to 0, obviously output will be 0 when you are. So this is the last reading for 100 ohms. It is 4.4 volt. So now you can find out load regulation is equal to V no load, means without any load. Here we have not connected anything. So here it is showing 4.88. This 4.88 minus V full load, that is 4.4 upon V full load, that is 4.4 into 100. So let's calculate this is equal to 0.10 into 100. From 200 to 1 kilo ohms, there is little decrease in output voltage, but at 100 ohms it decreased from 4.8 to 4.4. He is keeping output voltage constant irrespective of the change in input voltage or change in output load current. This is the simplest type of voltage regulator circuit. This Zener diode rating is 5 volt, that is why we are getting 5 volt. If you want 12 volt, then you have to replace this Zener diode with 12 volt, or you can replace with 24 volt Zener for 24 volt. So that's all about this experiment. Goodbye.